In this episode of the 3D Printing Gauntlet, we'll be throwing Myminifactory files at the latest edition of Prusaslicer and a Ender 3 with a modified direct drive extruder. Let's get started. How's it going, guys? Angus here from Maker's Muse and welcome back to another 3D Printing Gauntlet. The whole point of this series is to show you how I would slice and prepare and 3D print models using a random selection of models from a certain website before we use Thingiverse. And in this video, we're going to use Myminifactory. And to do that, I'm going to use a random number generator to find 3 models. And to do all this, we're using the latest edition of Prusaslicer. Now, this is a release candidate, but by the time this video is been circulating for a bit, the latest version of 2.2.0 will no doubt be out in the wild, and I don't think there's going to be too much change. But the one thing I like about the latest Prusaslicer is that it has inbuilt support for other printers other than those provided by Prusa Research. And specifically, it has it for the Ender 3, which is really cool to see, you know, a company supporting other brands of 3D printers. And I'm sure, as you know, the Ender 3 is hugely popular, so I thought it'd be a great combination to show how I would slice files for that printer using the latest edition of Prusaslicer. So without any further ado, let's get our first model. So for this challenge, there is a few rules. Number one, I'm not going to print anything that could be deemed illegal in Australia. So, I mean, there's a big thing about 3D printed weapons and that. I'm not going to do any weapons, I'm sorry. Even if it's a cosplay thing, I'm not going to take the risk. Secondly, I'm not going to buy any models. There's some fantastic models you can buy on Myminifactory, but for the purpose of this challenge, I'm not going to purchase them just because it's just about the slicing, not so much actually having the model at the end. I'm not saying anything's wrong with buying models. I sell models, but for this, I'm not going to be purchasing them. And finally, if I deem it to just be really boring and not a difficult print, or otherwise lower quality, I will skip it. Because I want to choose 3 models that are very different so I can show different slicing techniques and different printing techniques. So here's how it works. We're going to go to fresh uploads and I'm going to grab the latest file that someone's uploaded, which is this one. And it's got a number of 113737. And I've got this random number generator, so I'm going to put in the minimum as 1 and the maximum as this and randomize. So we got 10492. Well, that might be quite old actually, so let's chuck that in, see what we get. Nandi God statue used with 3D scan. Okay, that's pretty interesting. So this is a 3D scanned model. It doesn't look overly challenging to print, and actually the picture is of the print itself. So that looks like a good example to show how to get the highest side detail. So we might mess with some layer height stuff. So we'll grab that one. Okay, and next we have 101249, so it's quite a long way away from that other model. Let's see what this one is. Okay, so this one's paid. Unfortunately, I'm not going to buy it, but it's a really, really nice model by looks of it. So it's definitely worth paying for models, but just for this video, I'm not buying files, sorry. And let's go with our next one, randomize 103163. 103163. This is, ooh, prosthetics. Okay, well, this is a large model, so I'm not going to print the entire thing, but I will print a part of it to show how I would print a complicated organic part on an FDM 3D printer. I think it's a great opportunity. I really do like 3D printed prosthetics. It's a really cool concept. So I will download that and choose a difficult part to 3D print of that. Okay, and for our third model, 59401. What is that going to be, I wonder? It's a little rhino. Okay, so this is another scan. Okay, so it's pretty cool, but it's very similar to the other 3D scan. Like they're two creatures, both organic models. I really would like something geometric to really show a good range. So I've downloaded this one. I might do it instead of the cow, but let's just fire up one more just to see what we come up with. Hopefully I want to get something geometric. How about that? We found one of Devon's models. So this is a really cool model. It's geometric, it's big, but we can scale it. It's not going to use too much filament. And I think it's a good example to show how to get a good wall, uniform wall finish and get a nice geometric model. So I'm definitely downloading this model from Devon. If you don't know Devon from Make Anything, where have you been? Go check him out. Link right there. And this is completely random, I swear. It's a completely random number generator. Devon's just very prolific. He's got so many models on Myminifactory, so it's not too surprising we found this one. Alrighty, so I've downloaded the latest release candidate 2 for the Prusaslicer 2.2.0, and just if you have Windows 10, it might be like, oh no, it's a scary program, so you can go to more info, and then run anyway. So this is 2.2.0 release candidate 2. As I said, the latest one of Prusaslicer will probably be out very shortly, so I'm just using the release candidate because it's the latest I've got access to now. But as I said, what's really cool is now there's built-in support, native support for other brands of printers without having to use profiles just grabbed off the internet. There's actually built in. So you go to Configuration Wizard. So what we're going to go to is Next. And as you can see, we've got all the Prusa family, which is neat. But then you've got other vendors. And Creality is one of the first ones you can get machines for. And the Ender 3 is there built right in to Prusaslicer, which is super cool. So I'm going to go Next. And then you can define it. But I'm just going with default. And then we're finished. And then you'll notice on the right-hand side, I have user profiles, which I've created myself. But under System Presets, we now have Creality Ender 3. Which is really neat because we've got a company supporting a completely different company using their free slicer. So we're going to start with that Nandi statue, which I've got here, and all the links will be in the video description to the original sources. So this was a 3D scan. So 3D scans is quite typical of a fairly average 3D scan, not a huge amount of detail. The triangle count isn't gigantic, but it still preserves some of the detail like the necklace and that. So with this model, the first thing I will do with any organic model is I'll go into print settings, and on support material, I'll generally leave support material ticked on, and yes, that's fine. I'll change my overhang threshold to something lower, like maybe just 25%. And the purpose of doing this is I just want to see where the overhangs are. So automatic support material will be generated where overhangs are, and then I can determine whether I actually need it or not. And it's a good way to start. So I'm just going to slice that and just get an idea of how the model looks. So after slicing, you can see here that the sort of snout of the Nandi is very much requiring support. And you also see the leg here overhangs quite a bit. This bit might not need it, but anything that's over thin air definitely needs support material. And I can demonstrate that by scrolling back through the layers. You can see this point here where the leg is, as it starts to form, goes right out over thin air. So these two layers, as they go out, would just droop down if there was nothing to support it. So you would either sacrifice quality and not have support on, or have support and you have to remove it, but then the layers are in place where they should be. You might be able to get away with that, but the head, as we go up, you'll be able to see, definitely not. It will build up literally over thin air. So this part here cannot exist without support. Otherwise, it would just fall away until the rest of the head catches up and it will come away. Okay. Now, a few other things about this model that you might notice. The top of the statue is a very gentle contour. And that means that when you get to the layers here, they get a bit rough, bit obvious. Same with the top of the head, and that's characteristic of FDM 3D printers using a constant layer height. So, how can we improve the quality of this print? Right now, it's not actually too bad. There'll be a little bit of support material. We can choose where we don't want that and where we want it. But what I want to do is try to get a slightly better surface finish on these areas. And Prusaslicer has had a variable Z layer height for quite a while, which means instead of being set at a certain layer height, and then currently we're set at 0.2, which is a good balance between speed and quality. You can actually change it to be lower or higher to change your print speed. So you get more quality, takes longer, or you get less quality, but then it's quicker. So vertical surfaces don't need a fine layer height, but those gentle contours do. And we've had the ability to change layer height dynamically for quite a while, but the latest Prusaslicer lets you actually change it using an adaptive mode. So as you can see here, the adaptive mode, we can change a slider between quality and speed. And if I just click that, it's going to try to figure out where we want a much sort of finer layer height for higher detail, and where we can get away with a coarser layer height for quicker printing speed. And it sort of now looks like it's a sedimentary rock. And you can see where it's detected for the top of the back here, it wants more detail. Top of the head here wants more detail there. But then areas like this with the cow, it doesn't need it, so it's gone with lower detail. It's very jagged and rough. So what we might do is actually just smooth that out a bit. So we might click smooth here. And to be honest, I'm pretty happy with that. You can keep going and you'll get a more of sort of a smooth gradient between the layer shifts, layer changes. I think that's pretty neat, and that's one of the newer features that I really think is handy when it comes to slicing these models and getting a better surface finish. Okay, so as you can see here, when compared to the previous one, we still have, a few layers where it's gotten coarse, but really it's done its best to make it as fine as possible. One thing about this variable layer height technique is it's across the whole XY plane of that layer, so you can't just do one area finer and one area coarser, it has to be across the whole plane. So there is limitations, but it's a really easy and free way to get just a little bit more detail out of a print without making it take forever by making like the whole model 100 micron layer heights, which is what we kind of used to have to do, or used to have to choose big chunks would be 100, then smaller chunks would be 200, stuff like that. So I'm pretty happy with this so far, but there's just a few things I will change, and it's some of it's like a personal preference. One is the infill, and the second is perimeters. So with this model, it's by default on 2 perimeters. So if you see here, it's got only 2 outlines, which usually is okay, but when it comes to capturing detail, sometimes, like coming up to the top of this leg, for example, you can start to see little defects where it's sort of not quite overlaid enough to cover the infill on the inside of the part. So what I like to do is go and change my perimeters to 3. I generally print with 3. Top and bottom solid layers, 5 and 4 for the bottom. That's totally fine as well. Depending on your layer height, you might increase or decrease this. But something I will change is the infill. Now, I am a firm believer in 3D infill. Since I've started using it in the older Prusaslicers, I became addicted. So one of the first 3D infills was cubic, which is really neat, and I'll just show you how that looks. So with cubic, it actually gives you a proper 3-dimensional infill, and it can actually make the part stronger in every direction. So you can see this is cubic. Really neat. I actually am a big fan of cubic infill. It makes the part stronger. It's not just a sort of single 2.5D style lattice where it's just a grid that's just repeated up. But one of the more exotic 3D infills that has been recently added, well, not too recently, but not many people use it, is gyroid. And honestly, initially with gyroid, I was a little bit hesitant, but it's a pretty neat infill. So this is gyroid, and I'm not going to pretend I know too much about the benefits between gyroid and cubic and other infills, but supposedly it's even stronger and prints quicker. And it's got this really neat curve that repeats. So I'm going to use gyroid, but this model doesn't need to be this dense. And that's one of the biggest mistakes newcomers to 3D printing make, is they make the models with too much infill. You only need enough to support the parts as it's building up. And as you can see, as the top of this cowl forms, it needs some support, but not that level. So I'm going to change my gyroid down to 10%. And that's going to give us this infill, which is going to be a lot quicker to print, use less material, but as it forms, I think, as you can see here, as it builds up these areas, there might be a little bit of, filament drooping in, but because we've got those 4 bottom and 5 top layers, I think we'll be okay. I think it'll recover and we'll be okay here. And then as the rest of the print builds up, it's gradual enough to not really worry too much about that infill. So I'm pretty confident with this. I'm going to save this off. We have a little bit of support material, but not too much. The printing time for this is 7 hours, which is quite long. You could increase the printing speed, for example, or you could go back and use less fine layer heights. You lose a bit of detail, but honestly, for a model this size, it's actually quite large. But for a model this size, I'm quite happy with it. So let's just quickly check our filament settings. And let's see, so filament, we've got 210, 215 degrees. That's okay for PLA, maybe a little hot for some machines. Cooling will be on at 100% after the first layer, so first layer will not have no cooling fan. And in terms of the heat bed, 40 and 40, I think that's fine as well. I'm using a easy peelsy sheet on my Ender 3, and that sticks down quite good even when it's not that hot. So I'm quite happy with that. It's going to save this off, and let's move on to our next model. Okay, next is the prosthetic arm. Now this is a big print if I was going to print all the parts. These are all of them just dragged onto the build platform, but it looks like the designers actually put some effort into making these parts printable from the get-go, which is really handy to see. They've done these little platters where each part is oriented so it won't need support material, or it needs minimal support material, and it'll maximize your print time. So For example, these are like little digits. That would print pretty good without support. Maybe you might need a little bit, but it's not too bad. But I want to print something a little bit larger. Let's go with this part here. This is a good example of a thin-walled object that can be challenging to print correctly. So I'm going to delete this, that one, and left of this one. Okay. All right, so how would one print this? This model is quite thin. Looks like to be only about 3mm or so thick. It has a few interesting overhangs. So this part here is overhanging thin air, so that will need support material if you want to print it. And we've got a few bores. Holes generally print okay, so you can see these holes here. Holes can usually form over themselves, and you might lose a little bit of detail at the top, but they'll usually print okay without supports. So we need to make sure this print A adheres to the print platform, and B has support material where required. So what I'm going to try is, this top part looks like it's actually a flat edge. I'm going to try flipping this model onto that surface instead. Let's have a look at this. Okay, so what we've got here is the model is at a slight angle, and that means now that this part will form, but this angle is a little bit sharp, unfortunately. It might still work, but it's not a bridge. A bridge is where it's completely flat and you can get away with having no support material over a gap. But if it's at an angle, you generally need support. So let's just try printing this, and support material was enabled, so we'll see where it wants it. Okay, so it wants to fill in that hole. Again, I said holes don't need it, so that's unnecessary, and it wants to fill in that gap there, which again, I don't know, I'm not convinced it's needed, because this part will need assembly anyway if it was used in its actual purpose. I think what we can get away with, if I just go back to print settings, is disabling support material completely, like that, and then slicing it instead. I think for this area here, where it starts building up across, it's pretty rough, but I think we could get away with it, and at worst case, you just use some side cutters to trim any little droopy bits of plastic. So that way we don't need those huge columns of support material, and I think this part would print pretty well. But I think this thin-walled object is a good example to show you some things you might encounter when printing things like this. So remember I changed my perimeters to 3? Well, often by default they'll be at 2, and let me just show you what happens when you use a 2 perimeter setting on a thin-walled object like this. So it looks totally fine, right? But as we scroll down to the actual model, have a look at this. So this tricked me up for years. So you can see where it's gotten a little bit thicker due to the angle, it's decided that, oh, I'm going to put like infill in. See that? So this model would actually not be as strong as you might think, because it's changing how thick the walls are and trying to put infill in. So you're taking down the bottom, it's solid because it's at a certain angle where it makes sense to have those 2 perimeters, but then it gets up and it starts going hollow and weird and putting infill in. So that's going to make your part variably strong in different areas and weaker in different areas, but also it's going to increase your print time because the head's going to be jumping around putting these ineffective bits of infill in. So a good trick for that is to just go and increase your perimeters again, but also it's worthwhile detecting thin walls. So it's always worth checking this if you're getting those weird sort of points of filament extrusion, which really are completely unnecessary. So if we tick that and then add perimeters to 3, you'll notice as we go down this model, it's now a really nice, solid model. Now there's a few areas where like it'll do a loop, but it can't do a solid line, so it'll change a little bit, but overall, it'll actually do a nice continuous extrusion, which means the part's stronger and the print takes less time because it's jumping around areas less. And finally, there's one more tip you need to know for thin objects like this, and that's bed adhesion. Now, they tend to be a little bit finicky with sticking to the bed, because as you can see, there's only a small amount of surface area holding it down. To increase that, we need something called a brim. It's so called because your hat has a brim. So that here helps increase our surface adhesion for the first layer. And in Prusaslicer, you want to go through to skirt and brim, and we can actually add our brim width in directly. I'm going to make mine nice and large, 6mm. Now, it doesn't really matter if it's big, because what happens is it's just one layer thick, is you can peel it away really easily. And here's our brim. So you can see it's pretty huge, but as the part gets tall, you kind of want that to avoid the nozzle possibly knocking off the bed. And as I said, it's just one layer thick, so it peels away from the part at the end really easily. Now there's one more thing we can consider, and that's to use variable layer heights again to speed this print up a little bit more. Now depending on the part, sometimes the gains aren't really worth it, but let's just see what we can do. So we've got a print time of 3 hours and 44 minutes. So let's go to part, variable layer height, and we want to change it for more speed, adaptive, and we're getting this, again, really sharp, weird lines there, so let's just smooth it out quite a bit. Okay, so that's pretty cool. So it's going to make this middle part print quicker, and then these parts a little bit slower. And it's telling me a print time of 3 hours, 39 minutes. So not much of a difference. And the one thing you need to consider with variable layer heights is it will change the surface finish. So you'll notice in the render, the preview, the surface finish looks different. It will look different in the final part as well. But honestly, we're saving a few minutes to get a little bit more detail in some areas. And as long as it hasn't affected our internal geometry, nope, that looks totally fine. So I'm happy with this part. I'm going to save it off and we're going to move on to our last model. Okay, here we have Devon's stepped bin vase. It's huge. That is too big for the Ender 3, but the thing about this design is you can scale it, and you'll notice it's solid. And Devon's designed it like that because it takes advantage of a special mode in 3D printing slices called Vase mode, or Vase mode, depending on where you're from. I say Vase, deal with it. So what we're going to do first is scale this down. So what I'm going to do is right-click it and scale to print volume. So this will be the maximum we can print, but also when I do this, I generally scale it just a little bit smaller than a defined print volume, because often when you print to the max print volume, you can sometimes right at the end run into some issues as the printer maxes out. And then here at the bottom right, we have the position, rotate, and size. So I'm going to make it just a little bit smaller, 200 high. Let's make it just 190. 190, that'll do. So just a little bit smaller to make sure it doesn't hit any limitations on the printer. Okay, now obviously if we print this just using the settings we've been using already, we're not going to end up with a vase, are we? We're going to end up with a solid object that just has no right to exist. I mean, why would anyone print this? It's going to waste all our filament. So let me show you how I'd prepare my slicer settings for a model like this. So print settings, layer height. So layer height, it's a big print and it's going to take a long time. 0.25. I think for this model we can get away with it. We'll have a look, but that's going to make our print take less time. Vertical shells, perimeters, and that doesn't matter because we're going to tick spiral vase. And that's going to change a lot of settings, and spiral means it just slowly moves up. There's no discrete layers really, it moves up continuously, so when that hits the previous layer's line, it's gone up by the layer height. So let's turn that on. Yes, it's changed a lot of things. And it's made our top layers 0, so we're going to end up with, a hollow rubbish bin or vase or whatever, and our bottom 4. So 4 gives us a nice solid bottom, which is what we kind of want. Okay, so we've still got our brim, which I will actually just disable because for a model like this, you don't need it. So let's go turn brim off again. Okay, and we'll slice that. And let's see how this model actually forms. So we have our first layer, which is quite a large first layer. And then it's going to go up bit by bit. And then start forming the spiral. Now, this design has some very gradual curves to it. You can see as it builds up, they're very gradual. And that's important because we've chosen quite a coarse layer height, 0.25. You don't want these layers to be too far from each other, otherwise they won't adhere to each other. Okay, I have to jump in here because it didn't quite work out. This is the resulting vase, and as I mentioned, 0.25 millimeters for the layer height was pushing it. Overall it worked, but some areas it just couldn't get there. So I'm gonna do a few tweaks to the settings to show you how I would improve this and make it actually work. And don't mind the ironing board. No, I'm not doing any house chores. It's for an upcoming project. Okay, so to make this work, I'm going to drop our layer height down from 0.25 to 2. It was pushing it in some areas and they just couldn't adhere to the previous layer. So I'm going to change our 0.25 to 0.2. And what I'm going to do is a neat trick where you can actually extrude more material from the same diameter nozzle. And to do that, you go into the Advanced tab and you have what's called extrusion width. Now, Most of these printers have a 0.4mm diameter nozzle. You can get different sizes, but generally the most common is 0.4. And usually when you extrude, you're extruding around that size, but it's never going to really be 0.4. Most printers are dialed in to extrude just a little bit more material. So you can see here in the Prusaslicer, it's dialed in for 0.45 default, and then different settings have different extrusion amounts. So what I'm going to do is change our external perimeter, which is the outside of the vase, to a larger number. And what it's going to do for us is give us a stronger end shape. This is already pretty strong due to the geometry, but it's going to give us a stronger end shape because it's going to extrude more material and a wider width line. But also it's going to mean you can step over the previous layer just a bit more because there's more width. So let's change our 0.45 to 0.75. You can play around with this. You can see how far you can push it, but I think that will be pretty good. So here we go. I sliced it with that thicker extrusion width and the slightly lower layer height at 0.2 in spiral vase mode. And we have a used filament of 107 grams, which is a little bit more than before. It's about 60 grams before. And print time of 7 hours. And you can see as it forms the areas that were questionable before. These ones here, they're going to have a much better step over, which means a much stronger end product with a better surface finish. So I'm going to send that one off to the printer. So this is the only one that didn't really work out, and it was only because I was a little bit greedy with my layer heights. Alright, how did we do? Well, I printed everything in this PLA, which is from Matt's Hub, which is an Australian team, not sponsored or anything, it just sent me some filament, and it actually had a really nice wind, and it printed quite nicely, so I figured I'd just let you know where I got it. I'll link in the description. But we'll start with the Nandi sculpture. Now, this actually turned out really, really nicely. I removed the support material off the printer, just pulled away really cleanly, tiny few wispy bits, but maybe because it was printing a little bit hot. But the thing about the variable layer heights is you can kind of see where they are. It is a 3D scan, so there's some weird imperfections that look like they might be layer heights or layer shifts, but actually that's part of the model. I've got a really harsh light on this so you can see the layers really cleanly. I'm not trying to hide any imperfections. But yeah, overall the print's really good. And the bit where we thought we might be able to see the top of the statue there, really can't see much. And under the actual nose there, the snout, very clean after I removed supports, so a really good clean print. Very happy with that one. Next was a bit of the prosthetics, and this one was interesting actually. It surprised me because the area where we thought it would droop down didn't. It actually, you know, printed really cleanly, but right next to it, can you see that on the camera? See that there? It's got this weird, like, thin bit. Maybe that's where the slicer decided that it didn't want that many perimeters and it dropped down by one perimeter and just made this little flat bit there. Really interesting. You can see our brim here as well. That was the 6mm brim. And as I did say, look, it really is, not only is it easy, it's satisfying as well. Just pulls away really cleanly like that. And then we're left with a thin part perfectly ready to use. And we use variable layer heights for this one again. And once again, you can kind of see where they sort of cut in and cut out. You can kind of see here, it was coarser, and then there you go, coarser, and then finer towards the top, like that. Very, very nice, clean part though. Very happy with this one. Printed like this. And the holes worked fine. So no supports needed, with just a little bit of consideration into the print orientation. Then the print that did fail, I'll start with the actual failure. This was the bucket, the bin. Printed too thin, and the areas where it failed, you can see pulling away like that. No good. But the one that did work is this one, which I'll have to zoom out for. Oh, that light really is very harsh for the skin tones. But here is Devon's bin, and I'll hold it to the camera so it focuses on that, not me. Yeah, there you go. Really clean results. This was with the larger, the higher nozzle extrusion width. This was with the 0.75mm, not the 0.45, and it's much stronger. But what's really funny is if you look here, there's actually a string. You can see that string there. And that was in the G-Code preview. I wasn't sure I was going to print, but it did. But, funnily enough, if you just... hours of entertainment. So someone's got to make a 3D printed musical instrument with strings. So overall, 1 redo and 2 successes, and that's going to end this 3D printing gauntlet episode. So thank you for watching. I hope you found this video useful. I know it's very long. These videos take a very long time to edit and prepare, as much as it looks like I just grab random files, which I do. The actual preparation and editing to make it coherent is actually quite difficult. So I really appreciate you watching to the end, and leave me some comments below if you found this useful, if you found like a new tool I mentioned that you didn't know existed in the new Prusaslicer. And there'll be links below to all the files and the software I used. And if you're not subscribed already to Maker's Muse, then I highly recommend and welcome you to. It's my aim to empower your creativity through technology. And I'm going to sign off now because that light is absolutely blinding. Thanks for watching, guys. Bye.